Welcome, students. In this class, we will study about dynamics, force, inertia, and momentum. In some of the cases, this is a new chapter in the syllabus. As we have discussed during the last lectures, we have discussed about the mechanics and motion, types of motion, and then we have discussed about the equations of motion. Now, our topic is for dynamics, force, inertia, and momentum. We will start with the dynamics. Definition of the dynamics is that branch of physics which deals with the study of motion of material objects. With discussing the causes of motion is called dynamics. One thing must be clear, during the time when you were studying about mechanics, you have not discussed about the causes of the motion. You have not discussed about the force. Without considering force, you have discussed the whole types of motion in other topics. But now you need to calculate force. You need to understand the effect of the force. So this is a branch of physics which deals with the study of motion of material objects with discussing the causes of motion in is called dynamics. These are some of the examples where sun star galaxies, how these are moving and what type of the force is acting on these objects moving in the circular orbit. Another one is example of fuel, which force is responsible to move the fuel. Now the dynamics is another example where which force is responsible to move the cycle on the surface. And another example is engineering mechanics. This is one of the trends, and the other parks, in the parks where the things, different things are used. And basically they are working with the principle of dynamics. And their construction, their working is based and linked with the dynamics. Now, what's the force? It's push or pull. It's an agent that moves or tends to move, stops or tends to stop the motion of the body. It can also change the speed and direction of the motion of a body. Suppose it's a wall and you are applying a force on this wall. It's a door and any type of the sheet. When you apply a force, this or push or pull, when you push, it moves backward. When you pull, it moves towards you. Similar is the case if you keep in your mind the definition of force. You are asked to move the wall, a heavy wall, a wall in the room. You start pulling, but you at that time, if anybody asks you, what are you doing? You will say that I am applying some force. You will say it's not moving. So your answer will be, it's not the case of motion or are not moving or at rest. It's a case when we are applying some force. We are trying to move. Whenever we are trying to move, like the case of the wall, or when you move like a small car, toy, you apply a force, it moves. Lesser is the force, lesser will be the speed. More is the force, more will be the speed. Similar is the case in case of football. You apply a force, you kick the football, it moves to the speed. More the force, more will be the speed. So this is an example when you are applying a force and it moves. So the force have the two parts. One is it moves or it tends to move. It stops or tends to stop. You see a truck is coming towards you and you stand in front of the truck and you start to stop. It's impossible to stop a moving truck, but you are trying to stop. But if a small toy or any other ball or football is moving towards you, it is more easier for you people to stop it. You have stopped it. So these are the two portions. Either you want to, either you tries to stop or you stop the moving object. This is the concept of force. Force is basically vector quantity. It's denoted by F. Its SI unit is Newton. Newton, represented with capital N. I will define 1 Newton force during the next lectures. Examples are, we can open the door either by pushing or pulling. A man pushes the cart. The push may move the cart or change the direction of its motion, stop the cart. These are three possibilities which can be there. Either he will be able to stop, either he will be able to move, or either he will change the direction of motion of the cart. A batsman changes the direction of moving ball by hitting. It's another example. Direction of motion has changed. Now these are the different examples. You know, a person is uh, pulling a rack of wood and moving it. Other one is a batsman. He is trying to change the direction of the ball. Here it's a player. Small force is required to move or to change the direction of a football. This is a card in a shopping mall. This is another examples where two persons are uh, applying push or pull over each other. This is another example when with the help of a finger you are applying a force on the wall, and wall is also applying a force on your finger. These are different numbers of examples to understand how the force is applied and what's the direction of the force. Now, how will you define 1 Newton? 1 Newton is that force which produces an acceleration of 1 meter per second square in a body of mass 1 kg. Kg. Look, mathematically F is equal to ma. This m is basically mass and this a is basically acceleration. Whenever you, this is a basic technique used to define mathematical formula. Put one along each other. 1 Newton force. Unit of force is 1 Newton. Put here one. Put one here. Mass is measured in kg. 1 kg. And put 1 meter per second square here, like this one. Then how will you define? You have to follow the proper sequence. What will happen? And when it will be 1 Newton force. If a force acts on a body of mass, this mass 1 kg, then what will happen during the next step? It will produce some acceleration. And if this acceleration is 1 meter per second square, then the magnitude of this force will be 1 Newton. Again, I'm repeating. You must follow a sequence to define such mathematical formulas or any type of the unit to define such formula. Here it's mass, and unit of mass is kgs. You can't make a sequence while first you indicate that the acceleration is produced in a mass of 1 kg, a force acts 1 Newton. No, it's not a proper sequence. Proper sequence is that when we apply a force on a body of mass 1 kg, it produces acceleration of 1 meter per second square. Then the magnitude of that force is 1 Newton. This is the way you will define the 1 Newton force. Now, inertia, another most interesting topic in the physics. It is the property of matter due to which an object resists any change in its state of rest or that of uniform motion. If a body is at rest, it will resist to change in motion. If a body is moving, it will resist to stop. So here is an example. This one is an example. It is asked during many times in different exams. The fruit is at rest. Due to when you shake this tree, the fruit falls. A question is asked why. Reason is that before shaking the tree, the fruit was at rest. Due to inertia, it was to be at rest. So that's why the fruit falls when the tree is shaken. On what the factors this inertia depends? This depends on the mass of the body. Larger is the body, heavy is the body, difficult it is to produce motion or difficult it is to stop the moving body. Greater is the mass, greater will be inertia, it means. So mass is the direct measure of inertia. Basically, inertia depends on mass. Its mathematical formula is I is equal to mr square in some of the cases, and during next classes you will study to calculate inertia of different objects. So on what the factors this inertia depends, this depends on mass. So this was one of the examples where you have studied about inertia. There are a number of other types of the examples. Number one, if you place a coin on a card and card is placed over a glass, if you gently push the card with the help of your forefinger, the card will move quickly and the coin falls inside the glass. If you are asked to justify the answer, your answer will be before application of the force, the coin on the card was at rest. And when we apply a force, the card moves. Coin was at rest, wants to be at rest due to inertia, so that's why it falls inside the glass. This is one logic. Similarly, if you are asked to define how the passenger standing in the bus, when it suddenly starts moving forward, then the passenger falls backward. But when sudden brakes are applied, the passengers move forward. So this type of the question have two portions. For this answer, you have to divide your body in two portions: upper portion of your body and lower portion, legs of your body. When a car is at rest, you are standing, bus is at rest, you are standing inside bus, both are at rest. But suddenly when the car starts moving, your lower portion of the body becomes in motion with the motion of the bus. But due to inertia, your upper portion of the body was at rest along with the lower. So it takes time to transfer the motion. So upper portion of your body was at rest. It wants to be at rest due to inertia. So that's why it falls backward. So what happened? Half portion of answer of the next reason. What happens when moving bus suddenly applies a brake, a driver applies a brake in a moving, fast moving bus, then you fall forward. Why? The reason is that when a car starts moving with a faster speed, our whole body is in motion with the motion of the bus. When sudden brakes are applied, a lower portion of the body becomes in rest with the rest of the bus. But upper portion was in motion due to inertia, wants to be in motion, so that's why our body falls forward. So this is one scientific answer, scientific logic or justification for the inertia. How it resists is when it is moving to stop, or when it is stopped, so it will resist to move. So these were few examples to understand the inertia. Now the next one is example, another example, fast, a fast moving child fast forward when his toe stumble against a stone. The reason is that the lower portion of his body stopped, but the upper portion of the body continue its motion due to inertia. So that's why wants to be in motion. So that's why he falls forward. So these are the different examples of inertia. Look, this is one example when a motorcyclist strikes against any hurdle. Then motorcycle is penetrated inside bus, but the person is moving ahead. Why? Because due to inertia, he was in motion. He wants to be in motion. So these are some examples of law of inertia. Will remain asleep. A student asleep, remain asleep. So these are some of the cartoon shapes to define the nature of the inertia. So look, this is another example. A driver is driving a car. Sudden brakes are applied. His body, uh, due to inertia, the car or any other type of the rickshaw, anything stops, but his head moves towards the windscreen. Why? Because he was in motion along the motion of the bus or the car and wants to be in motion. So that's why due to inertia moves forward. And this is the reason why you are supposed or asked to wear seat belt. Why? Because due to inertia, your body possibility of motion of your body towards the windscreen is more. So that's why to prevent any type of head or other types of injury or collision, you are supposed to wear belts. It is in accordance with inertia. Similar is the case when you are using shocks in the car, and number of thousands of applications of inertia are considered whenever you are constructing some buildings, construction of some machines or heavy constructions. You have to consider inertial factor so that it becomes easier to make it safer. So other one is today's topic is momentum. And in case of momentum, definition of momentum is that the quantity of motion in a body is called momentum. Quantity of motion. The simplest is the product of mass and linear velocity. P, momentum is written with P, and its nature is it's a vector quantity, and its formula is P is equal to mv. M is mass and V is velocity. So that's why it is product of mass and velocity. So here it is. Mathematics. Mathematically, P is equal to mv. SI unit, its unit is right on the units of mass, it's kg, and right on the unit of velocity, it's meter per second. So combine, its unit is kg meter per second or Newton second. How it is calculated? By multiplying and dividing with second. So it will be kg meter per second square one. It will be equal to Newton. The other one is second remaining, and it will be Newton second. So I will explain during the next classes how proof of Newton second, from where you are getting. Simply I'm telling kg meter per second means you are multiplying with the dividing with the second and multiplying with the second. It will be one will combine with the kg meter per second to become Newton, equal to Newton. Other one will be remaining. So there are two units of basically momentum is expressed in two unit. One is kg meter per second, other one is Newton second. And what the factor is depends. It depends on mass of the body. It depends on the velocity of the body. What are the examples? You take a gun. With the help of a gun, you fire a bullet, and the same bullet you throw with the hand over a person, which will make the more damage. Of course, the bullet which is fired with the help of a gun. Why? Because the mass is same, but the speed is more and more in case of the gun. But in case of hand, it is less. In case of gun, its momentum was more, so its damage will be more. But in case of your hand, due to less velocity, its momentum was less, so the damage was less. So this is formula. P is basically is used for momentum, M for mass, and V for velocity. So these are some of the examples of the momentum is transferred. If this oscillating ball strikes with other ball, it produces motion in the other ball. So this is the concept of a momentum. So in this class, what we have studied about, starting from the first one, we have defined dynamics. We have considered the different examples of the dynamics. Then we have defined the force, unit of the force. Then we have defined of inertia and unit of inertia and factors on which the inertia depends. And at the end, we have discussed about the momentum and on what the factor momentum of a body depends on the nature of the momentum. With this, this class ends. Thank you very much for your patience. Hope you people have understood it, and write on the main points which we have discussed during this class. I thank you all.